Welcome back, statistics students. We are still inside chapters 6 through 8. Okay, we're on to example number 6 from the Monopoly examples. If you're just joining us, you need to go back and at least watch the first video, which is going to show you the data for the Monopoly. But we're on to example number 6, and it says find the coefficient of determination and interpret its value. Well, the coefficient of determination, don't forget, this is known as r squared, which in my last video, video number 5 here, I did the r value, which I actually showed you how to get this thing over here that I'm kind of hovering over. And we did this r value already. Now we're doing r squared, which is just r actually squared. And here, that's a terrible r. When I look at r, right, and the r squared value, it is equal to 0.77, really. Okay, and what we're going to do is, this is r squared, so it says find it. Okay, we found it. And what I did on the last video is kind of open this up so I could see a little bit better, and I think I'll do that here too. Okay, so when I'm looking at this, I need to now interpret its value. Okay, which this is not terrible, but remember, there is a very easy way to do this, and I'd like you all to do it this way every time. And we say, we start with 77, we make this into a percent, 77% of the variation in, now we hit whatever our x variable is, right? Or I'm sorry, variation in our y variable, because that's the one that's varying, right? In property cost, right, that was our response variable, okay, is explained by the linear relationship. Linear is important here, with property spaces from Go. Okay. Now, some things to really hit home. This part right here is our explanatory variable, which I did explain why this is the response variable and the explanatory variable in my very first video as well. So I'm saying 77% of the variation in property cost is explained by the linear relationship with property spaces from Go. As I change this variable, right, spaces from Go, that change explains 77% of the difference in cost. Okay, so that is the easiest way to interpret an r squared value. Okay. Now, what we end up doing a lot, okay, what we end up doing a ton with r squared as well, is we end up talking about whether or not this is a good model, right? We created this model, and using r squared, 77%, is that bigger than 50%? Yes, okay, so this is greater than 50%. So what we usually end up saying as well is, because r squared is high, this is a good model for making predictions. Okay. If it was a low percentage, right, less than 50%, we would say that it is not a good model. Okay, and we'd have to look for a different model. That is example number 6. Okay, coming up, I will do example number 7.